Hi guys, today we'll be looking at section 1I, perpendicular and parallel lines. Learning intentions to know what it means for lines to be parallel or perpendicular. So parallel means two lines are never ever crossing each other. And perpendicular means two lines has formed the right angle 90 degrees. Okay. To know that parallel lines have the same gradient, to know that the gradients of perpendicular lines multiply to -1, to be able to determine if lines are parallel or perpendicular using their gradients, to be able to find the equation of a parallel or perpendicular line given a point on the line. All right. So these three figures just told you what the transversal line looks like. So a transversal is a line that cuts across two or more, usually parallel lines. Okay, so these transversal line has cut crosses two lines. All right, and don't worry about those ones. Let's go straight to key ideas. Two parallel lines have the same gradient. For example, y is equal to 3x minus 1 and y is equal to 3x plus 8 have the same gradient of 3. So just to remind you, y is equal to mx plus c, and that's our gradients. So gradient intercept form. Okay. So to read your gradient from the equation, we just look at the coefficient of x. So they both have 3. And I'm going to use decimals to show you how it looks like. So we have our first equation, y is equal to 3x minus 1. And you're going to see something like this. Okay, a straight line like this. And we have our second equation, y is equal to 3x. Let me see, a y-intercept plus 8. Okay, plus 8. It's something, the blue line. All right. You can see they are parallel because they have the same gradient. Gradient means how steep, the steepness of this line. So they have the same steepness. And in fact, if I have y is equal to 3x plus c, all right, and add a slider of c, you're gonna see this line is always parallel to these two lines. Okay, so no matter what c value is, this green line is parallel to these two lines. All right, so that's why we say as long as we have the same gradients, these two lines are parallel. Okay. And next one, two perpendicular lines with gradient m1 and m2 satisfy the following rule. The product of m1 and m2 is equal to -1. Okay. So, for example, I have 3x minus 1 as my red line, okay, as my line. And which means my gradient is 3. My gradient is 3. And it's 3 times my second gradient of the line is equal to -1. Okay. Therefore, m2 is -1 over m1. -1 over m1. m1 is equal to 3. So the gradient is going to be equal to -1/3. Okay. So y is equal to -1/3 x. And you're going to see a line that is perpendicular to this red line. I can plus c. So, add a slider. You're going to, no matter what c is, so no matter what c is, it's always perpendicular to these red lines. All right. So as long as we satisfy the products of m1 and m2 is equal to -1, this happens. Equation of parallel or perpendicular lines can be found by finding the gradient m, then substituting a point to find c in y is equal to mx plus c. We're going to explain this a bit further in our example questions. And with this proof, if you're interested, have a look at it. And feel free to let me know if you have any questions or concerns. The more important is to use those results. Okay, the more important is to use those results. Okay, example 1. What is the gradient of a line which is parallel to y is equal to negative 3 over 2x plus 1? So parallel means implies same gradients, okay, same aim, okay, the same aim for both lines, okay, same aim. So you look at your aim here, this is your aim, therefore the gradient m2, let's say this is our m1, m2 is negative 3 over 2, okay, they have to be the same to make it parallel. All right, perpendicular to that, so that's our m1, and then we know m2 is negative 1 over m1, all right, or just remember it as m1 times m2 is equal to negative 1, both works, okay, so or therefore m2 is equal to negative 1 over negative 3 over 2, okay. Negative 1 divided by negative 3 over 2, it divides a fraction, you gotta flip it, okay? Negative 1. And remember this negative, 2 negative make it positive, okay? 2 negative make it positive. So it becomes 1 over 3 over 2. It's 1 times, you flip the number, times its reciprocal, 2 over 3. So it's 2 over 3. All right, so the gradient m2 has to be 2 over 3. Otherwise, you just use this. They are essentially the same. We have just rearranged this equation. So m1 is negative 3 over 2 times m2 is equal to negative 1. So m2 is equal to negative 1 divided by negative 3 over 2 with times its reciprocal times negative 2 over 3. Okay, so it's 2 over 3. So both work. It's just depending on what you like. Example 2, a line is parallel to the graph of the rule y is equal to 3x minus 2 and its y-intercept is 4. Sketch these two lines on the axis below. Okay. So let's sketch this first line. We'll have our negative 2 as our y-intercept, and the gradient is equal to 3. So 3 is our gradient, m1. 3 is equal to rise over run. Okay. So 3 could be written as what? As 3 over 1, which means it's got run for 1 unit. It's got run for 1 unit, and 3 and rise for 3 units. Oh, so negative 2 units, and 2 here. So that's the 1. So that's our 3 units. Okay, so 1 unit to the right, 1 unit to the right, and 3 units to the upwards, and then connect these 2 dots. Let's try to, yep. All right, and now this line is parallel to this, parallel to 3x minus 2, and this y-intercept is 4, right? So to make it parallel, it's got the same gradient. So we could do rise over run, and we know the gradient is going to be 3, okay? So m2 is going to be 3 as well. m2 is going to be 3 as well. So your rise over run is going to be 3 over 1 as well. So 1 unit to the right, and 3 units up, so to 7, right, to 7. And there we go. We connect these 2 points. It's not so, okay. All right, here we go. See, they are very parallel, okay? They are parallel. Write down the equation of this new line in the form y is equal to mx plus c. Okay, we know the gradient is definitely going to be 3. It's the same, right? Look at that. The gradient has to be the same as the previous line. So, and our y-intercept is going to be negative plus, let me see, our y-intercept is positive 4. Okay, so make it positive 4. So we can just write it out. Y is equal to 3x plus 4. Okay. Ax plus by is equal to 6. So we're going to change it to rearrange to get this form. This form tells us x and y are on one side. X and y are on the same side. So we're starting from this form, and y and 3x are not on the same side. So I'm going to move my 3x to the left. So I have negative 3x plus y is equal to 4. Okay. And then I've got this format, negative 3x and y in the same side and one number to the right-hand side. Example 3, decide if the graph of each pair of the rules will be parallel, perpendicular, or neither. So the first one, negative 4 and 1/4 are definitely not the same. So it's definitely not parallel. We just need to check if they are perpendicular. So m1 times m2. Your m1 is negative 4 and your m2 is 1/4. That's negative 1. So which implies perpendicular. Okay, perpendicular. And next one, they're definitely not the same. So let's do m1 times m2. 1/2 times 2 is going to be 1. So it's neither. Okay, it's not negative 1. So it can't be perpendicular. It's just neither. And next one, C, be very careful. When we're talking, we're only talking about gradients. So you gotta work out the gradient first. The first equation, rearrange it. 5x. Yeah. 5x, and then move my 3y to the other side. Okay, 3y minus 10. Okay. And I want to get my y by itself because I want the form. Let me write in a different color. I want the form into gradient intercept form. So it's going to be y is equal to mx plus c. Okay, I need to get my y by itself. Now I'm gonna plus 10 for both sides. I have 5x plus 10 is equal to 3y. All right, and divide by 3 for both sides. Divide by 3 for both sides. I have 5/3x plus 10/3 and it's equal to y. Okay. Therefore, it's writing in this format. Y is equal to 3/5. Write it again. 5/3x plus 10/3. Okay. Next one. 5x, starting with 5x is equal to 3y plus 2. Again, we don't want to get y by itself as gradient intercept form. So 5x take away 2 is equal to 3y. So y divided by 3 will get 5/3x minus 2/3 is equal to y. So your y is equal to 5/3. 5/3x minus 2/3. And you could find both m1 and m2 are equal. Therefore, they are parallel. Okay, so they are parallel. All right. Last example. Find the equation of the line that is parallel to that and pass through the point 3, -4. So if it's passing through, if this line is parallel to this line, its gradient m has to be 2/3. Okay. Therefore, our gradient intercept form tells us mx plus c. So our m is 2/3 and x plus c. All right. And my y is equal to that. And now I can just substitute 3, -4. All right, because this line has passed through this point, which means this point lies on the line. Okay, which means your x and y with x and y coordinates satisfy this relation. So -4 is equal to 2 over 3 times 3 plus c. We could solve for c. So -4 is equal to 2 plus c. And take away 2 for both sides. -6 is equal to c. Okay, c is equal to -6. So therefore the equation is y is equal to mx plus c. M is 2 over 3, x plus c. C is -6. So plus -6 minus 6. Perpendicular to that. So perpendicular to this line. We know if it's perpendicular, the product of m1 and m2 is -1. We've got our m1 is 2 over 3. 2 over 3 times m2 is equal to -1. Okay, so to find m2, we use -1 divided by 2 over 3. 2 over 3. Okay, so m2 is equal to -1 times 3 over 2. So m2 is equal to -3 over 2. Once we got here, we're going to do exactly the same thing as we did for last question. So substitute 4 comma -1. Okay. We know that m2 is -3 over 2. So y is equal to -3 over 2 plus c. All right. Y is equal to -3 over 2 plus c. So y is equal to -1 and -3. Sorry, I forgot my x. 3 over 2 times x, 4, and a plus c. So -1 is equal to 3 over 2 times 4. That's going to be -6 because 4 over 2 is 2. 2 times 3 is equal to 6 plus c. And plus 6 for both sides. I have 5 is equal to c. Okay, so c is equal to 5. Therefore, y is equal to -3 over 2x plus 5. Okay, last part. Perpendicular to x is equal to 7 and pass through the point 0, 3. All right, this is a bit special because x is equal to 7. It's a vertical line. So that is our x is equal to 7. And passing through the point 0, 3. Let me use a different color. 0, 3. Okay, so that's 3 here. So if it's one perpendicular, it has to be this line. So it has to be y is equal to 3. Okay, to make it perpendicular. Look at the y coordinates here. It's 3. Therefore, you can just state the result. Y is equal to 3. Okay, so the line y is equal to 3 is perpendicular to x is equal to 7 and passes through the point 0, 3. All right, and now it's your time to finish your work. Thank you.